three law of motion. Okay, first Newton's law, which in conclusion we may state, okay, we may state that total F, okay, total net force equal to 0 for the first law. For the second law, total force, dia ada motion, acceleration, okay, which the velocity menyumbang kepada acceleration. So kita restate balik the statement on law of motion tu, so that kita kata acceleration tu adalah the ratio of net force to the mass. Okay, and today we're going to see the applications of Newton's law. Alright, so here, okay, suggested 5 steps, okay, so that easier for you to solve for case yang related to Newton's second law of motion. Memang nama dia application of Newton's second law of motion, but we cannot macam mana nak cakap, kita tak boleh pisahkan, bukan separate lah, kita tak boleh pisahkan dengan first Newton's law. Okay, sebab first Newton's law ni kebanyakan case dia akan ikut juga, even that case is second Newton law. Sometimes that first Newton's law help us to find the other equation so that we can find the other unknown, or we can solve that problem lah. So here at first we will start with identify the object whose motion is considered. Okay, so tengoklah objek tu yang mana kan. And then bila dah tahu objek mana yang kita nak consider, sebab sometimes we have 2, 3 object, okay, in a case, alright, in a situation tu. Right, so you need to decide. Okay, because macam saya cakap, contoh mudah for case yang apa ni? For case contoh for case tension. So let's say we have 2 body here. So we have if we refer to this body, okay, then tension is in this direction. And another one is in this direction. When we refer to this body pula, dia ada ni. And then tension in this direction. Okay, so that's why we need to identify. Tapi dia kata whose motion is considered tu, maksudnya sebab kita refer pada yang ada acceleration. Okay. So that's why dia kata yang ada motion lah. So bila satu tali tu pergerakan dia macam mana? Acceleration dia sama ke tidak? Nanti kita akan tengok. Sama ada dia share acceleration ataupun macam mana kalau case yang connected. Macam tu lah. Alright. Determine the forces exerted on the object. Okay, so when we already identify the object, contoh kita nak fokus on this object. Berapa acceleration dia, move ke atas ke bawah ke nanti. Okay, so kita akan determine pula lah the forces exerted on the object. So that from there we can determine the acceleration of that object. Contoh, okay, kalau dia punya unknown is acceleration. And then after that we have the force, then ini awak punya sketch, then transfer pada free body diagram yang betul lah. So daripada sini transfer pada free body diagram yang betul. Again, bila free body diagram yang betul sebenarnya cuma ada yang punya vektor saja. So satu ke atas, satu ke bawah, come up from a point saja sebenarnya. So label lah, contoh for this case T2 going to towards the earth tu we have FG kan, gravitational force kan, contoh, right? Okay, so here this is the definition lah for free body diagram. Dia kata showing the chosen body by itself with vectors drawn to show the magnitude and directions of all the forces applied to the body by the other bodies that interact with it. That's the definition for the free body diagram. Macam saya cakap semalam lah. So today we use the free body diagram. Okay, kita tengok macam mana how to do the free body diagram. Choose a system of coordinates so that calculations may be simplified. Okay, yang standard one, we're going to choose coordinates yang beginilah. Sistem koordinat begini X, Y kan. Okay, but for certain case, sometimes we need to shift the angle a little bit, depends on our plane. Because we want our normal force always to along the y axis sometimes. Okay, jadi kita akan tengok. Apply the equation above. Apply the equation above tu maksud dia net force ni lah. Kena sama dengan MA. Okay. Pada pilih sistem koordinat kita, apply equation above. Okay, so maksudnya yang ni tadi, koordinat sistem ni kena match lah dengan vector, your vector diagram tadi, your free body diagram tadi. Okay, bila dah tu, then kita apply. So, macam ni, on a plane of X and Y, so means that the equation akan ada along the X axis and along the Y axis. Okay, kalau tak nampak yang bawah, bagi tahu saya ya. Alright, let's see an example here. We have an example here. Alright, 3 wooden blocks connected by a rope. Okay, by a rope of negligible mass. Dia kena ada mention perkataan negligible mass. Kalau tak, dia jadi masalah jugalah. Sebab kita kena consider mass tu, nanti dia pun ada W juga arah bawah semua. So, dekat sini pun kita akan ada free body diagram untuk dia. Gitu. So, kalau dia kata negligible mass, okay, dah settle satu masalah kita. Then, we just need to focus on these 3 bodies saja. M1, M2 and M3 being dragged by a horizontal force. Okay. Figure ni lain, nombor figure ni lain lah. Apalah. Okay. So kita ada applied force here in this direction to the left. So this is your T1 and T2. Again, I explained, as I already explained before, tension in a rope ni will have a same value but in different direction depending on the body that we refer to. Okay, contoh macam we refer to M1, so the T1 will be in this direction lah. Okay, then when we refer to, kenapa ni? Tak boleh. When we refer to this M2, okay, then T1 is in this direction. Alright, let's see. Okay, so given, applied force given 1000 Newton, M1 given 3 kilogram, M2 given 15 kilogram, M3 given 30 kilogram, determine the acceleration of block system, tension of the rope, neglect the friction, settle lagi satu masalah kita between the floor and the wooden block. Okay, so memang dah settle banyak lah masalah kita sekarang ni. Alright, so the acceleration. Let's see how the solution. So we have F and T1 for our first body. Again ya, macam saya cakap, since all these 3 blocks is connected, okay, then the acceleration will be the same. The value will be the same ya. Okay, so samalah sebab dia connected kan. And then rope tu pun massless, friction tak ada, then all we experience the same value of acceleration. All will move with same value of acceleration. Alright, so we start with our first free body diagram for M1. So acceleration in this direction lah, since applied force is in this direction. And then T1. T1 is for tension on the rope, okay. And then from here, okay, the net force. So the net force that in X component, okay, so what is in to the right? To the right is T1. To the left is F and equal to negative MA. But here, okay, but here, ada lagi satu mazhab, ya. It will use that the force, that same direction with the acceleration, we take it as positive. Ada lagi satu mazhab macam tu lah. Tapi saya tak prefer you untuk guna yang tu. Because saya nak awak memang tak confuse, saya tak nak awak confuse, okay. So I want you to, I prefer you, I suggest, okay, I encourage lah. Tapi but it's up to you. Sebabnya ramai dari sekolah, maksudnya sekolah menengah memang your secondary teacher memang akan ajar yang macam ni. Yang macam ni lah. Okay, but I'm not prefer this because saya suka yang mudah. Sebab saya tak suka ingat banyak-banyak. Nanti saya serabut. Jadi saya ambil yang kanan, tolak je yang kiri. So this one akan jadi T1 minus F equal to negative M1A. Then when we rearrange this equation, then we will get the same equation je sebenarnya. Okay. The same equation je. Okay, it's just cuma cara kita nak ambil the negative positif tu lah. Okay. Macam yang ni sebab apa dia ambil yang MA ni positif, F ni positif. Okay, sebab dia assume yang mana sama dengan direction of the acceleration, then that force yang akan jadi positif and opposite pada dia yang akan jadi negatif, opposite to the force yang menarik dia tu. Macam tu. Right, so it's up to you. Kalau you dah biasa cara tu, no problem. I only suggest and encourage saja. It's not a must. Okay, it's up to you. Okay. Mana yang awak selesa, okay je. Sebabnya tak ada salah sebab suppose you get the same value of the acceleration. Either one yang awak guna pun akan dapat sama. Alright, so we substitute the value lah so that we see whether we can solve one of the value or not. But still not. We still have two unknown. T1 plus 3A equal to 1000. So we have two unknown. So we need to find another one equation. Alright, so block M2 equal to 15 kilogram. Then how the free body diagram looks. So it look like this. Alright, so T1 in this direction. Okay, sebabnya tali dia kat situ. Again, dia kena away. Tension, how to draw the tension direction away from the body. Alright. And then from this, kita transfer pergi equation again. It is in X component. Please note that net force for X component on M2 is T1 minus T2 M2A. Yang ni pun sama. Okay, ni pun sama. Dia ambil sama direction dengan tu. Tapi kalau macam kita biasa ambil yang ke kanan, tolak yang ke kiri, ambil yang ke kanan, tolak yang ke kiri. Ataupun macam tu lah. Ambil ke kanan, tolak yang ke kiri. Ataupun kalau yang macam lecturer metrik saya ajar, apa yang ke kanan letak sebelah kanan, apa yang kiri letak sebelah kiri. Cuma nanti awak tak tahu nak letak punya MA tu lah kat mana kan. So before that maksudnya minus yang tu kanan tolak yang kiri macam tu. Senang fikir satu benda je kan. But it's up to you. Saya tak ada masalah. As long as you get your final answer then no problem. Alright. Then you substitute the value, then we still have 3 unknown here. So means that we need to find another one equation because 2 equation is not enough to solve 3 unknown. 2 equation is not enough to solve 3 unknown. So we need to find another one using our third block. So this is the force the only force that act on M3. So from here we get the value of T2 equal to 30A. This is our third equation. So from here, since we want to solve on acceleration, so focus on acceleration, so make sure the substitution, okay, give you value of acceleration. Maksudnya kita tak naklah cari tension dulu. Sebab tension jawab soalannya berada di nombor B. Okay, so now slowly, okay, slowly solve the all the equations. Okay, rearrange that equation and we have the acceleration equal to 20.8 meter per second squared. Alright. Okay, then settle masalah. So make sure, maksudnya macam saya cakap tadi lah, make sure bila awak substitute tu, make sure your acceleration yang awak dapat value. So kalau awak dapat value untuk T1 dulu, T2 dulu, then baru dapat acceleration, then takut waste your time. Then bila dekat B, awak pun cakap dekat examiner, sila rujuk jawapan di atas. Takut examiner tak berapa berkenan cara awak tu. Okay, that's why saya encourage you. Please answer the question. Baca soalan betul-betul. Kalau A nak acceleration, cari acceleration dulu. Don't need to find the other things. So that it will save your time. Okay, sebab dalam exam kita mengejar masa. Macam saya cakap, kalau fizik, kalau awak faham konsep, sejam pun sebenarnya awak dah boleh siapkan. Okay. Kalau faham konsep. Sebab calculation dia very simple. Okay, so because kita bukannya nak test your punya mathematics. Mathematics nanti kita test kat mathematics lah. Okay, so physics we test your concept. Alright, and then for B, since we have another two equation that to be solved, then we may find your another two tension. Okay, so masuklah daripada equation yang tadi kita dah list down tadi. Alright, so solve for the other two tension. Next, we see another one example with rope hold two blocks, okay, connected, and then dia ni ada pulley lah. Okay, ada smooth pulley. Settle lagi satu masalah kita bila ada kata smooth pulley. Okay, why? Because we don't need to consider the torque. Okay, if not, pulley ada force. Force, we call it as torque. Force yang berfusing. So kita kena consider dia punya tu pula. So this time no need. We can focus on these two bodies saja because these two bodies saja yang ada mass ataupun yang memang function. Alright. So and here two object mass 10 kilogram. Okay, connected by a light string. Settle lagi satu masalah kita. Alright, so don't need to focus on the weight of string. Alright, so we have only two body that yang function lah untuk this case. So find the acceleration of the object of mass 10. Okay, acceleration ada S ke tak ada? Tak ada. Sebab apa? Sebab acceleration dia nak satu sebab dia nak 10 kg and kebetulannya acceleration for this case adalah satu sahaja. Okay, cuma yang ni in this direction, the other one is in this direction, the acceleration. So different in the direction. Alright, but for this question, sebab tu dia specify kan, dia kata dia nak at 10 kg, on 10 kg punya mass, okay, what is the acceleration, which is yang ni lah. Alright, so you need to focus on this and again, is bila kata, tapi dia kata calculate sepatutnya tak payah, tapi bila acceleration is vector, so bagi je lah, bagi je direction, maksudnya direction to upward ke apa ke, bagilah. Alright, so calculate acceleration. So again, we draw free body diagram. So for M1, okay, we have this free body diagram. Right, so see the equation. So we get this equation. So from the free body diagram, kita akan transfer. So apa force yang ke bawah? Force yang ke atas akan tolak force yang ke bawah, equatekan dengan M1A because this is under second Newton's law. Alright. Then from here, since this again Saya cakap bila rope tu connected macam ni, okay, memang dia terpisah dengan puli ni. That's why dia kena kata smooth pulley. Ya, sebab apa nanti bila awak dah belajar nanti puli yang berfungsi, maksudnya puli yang not smooth fully, the tension value akan lain. Okay, for this time being, the tension akan sama because it's connected together and smooth pulley. That's why saya kata pentingnya perkataan smooth pulley ni. Like string ni pun very important to highlight. Okay, so for case yang smooth pulley, then your tension is the same when it connected like this lah. Selagi dia connected, then a tension saja but different in direction. Macam soalan ni pun dia kata the tension in each string. Sebab apa dia kata in each string? Tension macam saya cakap magnitude sama tapi different in direction. So dia kata in each string, maksudnya mungkin dia nak kata yang M2 ni berapa, okay, tension dia, so kita ada magnitude yang sama tapi different in direction, so kena beritahu lah tapi dia boost ke atas lah. Right, kebetulan yang ni boost ke atas. Alright, so when we simplify the equation, we get this equation, our first equation, and again when we have two unknown, then we need to find another one equation. This is our first equation, find another one equation from the other one blocks. Okay, so we have this free body diagram. From the free body diagram was in upward minus the downward, but this time again macam saya cakap dia ikut yang sama arah dengan acceleration yang positif. Nampak tak ni? Dia ambil positif, yang opposite arah acceleration dia ambil negatif. So yang acceleration ni. Tapi kalau saya biasa buat, saya akan buat T2 minus your M2G equal to negative MA. So it's up to you lah. This is only my suggestion lah. Alright, so it's up to you, no problem. Mana yang awak biasa, mana yang awak selesa ya. Okay, so we substitute the value, then we get the second equation. Then we solve that two equation and find the acceleration. To find the B, the tension, then we substitute and we solve for another one unknown which is the tension. Right, so again sebab dia tanya tadi in each string, so please answer question. So T, jangan tinggalkan macam tu, kena mention T1 T1 sama dengan T2 sama dengan that T yang we find from the yang ni tadi, which is equal to this one. Faham tak? So make sure you menjawab soalan, bagi clear. So kalau awak buat clear, so examiner gembira, dapat markah lah. Tak dapat markah lebih, tapi dapat markah semaksimum yang boleh. Alright, then we go to this question. Alright, so since this question is on application on second Newton's law, so it's about object that we give force, we apply force on that object and it will have acceleration. Okay, so that's why dari tadi kita cari acceleration saja. Alright, and then for this case, two blocks A of mass 10 kilogram. Okay, of mass 30 kilogram are side by side. So here dia ada contact with each another. Macam ni ya, dia contact di sana. They are pushed along a smooth floor. So settle satu masalah kita, sebab apa? We don't need to consider the frictional force, right? And then given the applied force already given, which is magnitude 200 Newton. Okay, apply at A side ni. Okay, so determine the acceleration. So to solve case A, sebenarnya we can assume AB as a block. Okay, macam tu cerita dia. Kita boleh assume saja. Dia macam satu objek. Then we can simply plus the mass. Okay, so macam dia satu mass, right? Then F here, so only this force act on these two bodies. Okay, then F je lah. Okay, so your net force is F. So equal to MA. Macam tu. So MA, but your mass is AB, A plus B. Alright, so you get your acceleration. Okay, so then one equation for one unknown then settle. Cuma bila B, the force exerted on A, by A on B. This one kita akan apply third Newton's law. Okay, so means that we need to consider asing lah that body. Right, so free body diagram. So mana datang FBA ni? Bila kita tolak F ni tadi, kan ada force yang menolak dia juga dari B. Gitu. So which is that one is action reaction force ataupun that one is macam yang third Newton's law punya explanation lah. Which is dia akan sama sebenarnya tapi negative direction saja. Alright, so nanti kita tengok. Alright, so F minus FBA equal to MAB. Okay, so yang ni yang tak macam tadilah. So tolak je apa yang ke kiri. Yang kanan tolak yang ke kiri. Ikutkan dengan MA, net force. The net force ya, bukannya force sahaja. Net force, net force. Alright, so you substitute your value of mass. And then you get your FBA. Okay, force by B act on A. Okay, so tu maksud dia lah. Okay, from the Newton's third law, thus FAB equal to FBA equal to 150 Newton or for the object B. Okay, so kita ada FAB saja. Ataupun kalau kita nak cari juga, okay. Boleh juga kita proofkan by calculation pun boleh, which is sebenarnya dia akan dapat value yang sama saja. Okay, so dia akan dapat value yang sama. Alright, macam tu lah ya. Yang ni second and third law. Okay. Right, so exercise 4.2. This one is up to you lah. Kalau you already get the concept, then you may focus on tutorials. Kalau tak, yang ni boleh practice, apa mana panggil? Boleh practice vectors juga. Okay. Sebab memang saya bagi case yang paling complicated lah. Maksudnya kalau awak boleh berjaya buat exercise ni, then insyaAllah apa saja soalan yang keluar kat final, then awak boleh jawab lah sepatutnya. Okay. Now we're going to see okay, case. Okay, some cases that we always ataupun yang kita selalu jumpa dalam periksa ke ataupun macam mana nak cakap ataupun in our daily life sebenarnya kita nampak benda ni. Okay, and then how to derive the equation. Okay, tu cerita dia. How to derive this equation when we have this some cases yang related to the basically the law of motion. Law of motion, tak kisahlah first, second, third ke kan? Right? Let's say we have very simple. So biasanya kalau case horizontal surface biasanya sudah memang boleh score lah kalau keluar soalan horizontal surface. Tapi ada je some student yang dia tak dapat that concept dan tak boleh jawab juga. Tapi bagi saya sangat sayang lah sebab dia memang very basic. So let's see sebab apa saya kata dia sangat senang. Sebab macam ni je. Macam tu je. Macam tu je. Okay. So consider a box of mass. Mana ni? Pull along a horizontal surface by a horizontal force. Okay. So maksudnya force dia memang horizontal ni. So maksudnya dah clear kat sini. Yang awak boleh terus letak matchkan dia pada coordinates dia yang standard system. Sistem coordinate yang standard which is your X in this direction, your Y in this direction. Okay. So for X component, so we start to form our equation. So Fx equal to F net equal to MA since here showing that it have acceleration in that direction or same direction with the force pull, okay, then we can write our equation like this. Okay, so force to the right minus force to the left then equal to ma. For y component, we have apa yang komponen apa yang ke atas going upward is your normal force, then we minus mg. Oh, dia dah terus tulis ni. Since equal to 0, that force y equal to 0. Sebab apa equal to 0? Sebab dia ada atas plane tu. Dia tak ke atas, dia tak ke bawah. Tak ada mana yang lebih. That's why saya kata normal and wake is not an action reaction pairs. Okay, it's not the new application of the Newton's law. Okay, sebab normal force is apparent wake. Dia is not always the same dengan your punya wake. Okay, so that's why it's not considered as your action reaction pairs punya force. Okay, so Fy akan equal to 0 bila dia memang lie on that plane or on that ground, on that table. Okay. Right. Dah habis so macam ni lah. So then depends. Sometimes banyak lah. Kadang soalan suruh cari expression. So carilah. Tapi basically kalau case yang simple yang begini, then this is only the equation that you need to derive. So contoh berapa unknown. So then 2 equation ni je lah. Biasa dia tak boleh bagi lebih 2 unknown. That's why jarang lah. Jarang. Tapi depends. Kalau macam kita dah ambil soalan lain tu susah, then yang ni kena jadi senang. Then mungkin dia akan keluar yang horizontal surface saja. Macam tu. So walaupun senang awak kena tahu jugalah. Don't take things for granted. Kan? Kalau tak boleh dapat markah bonus je. Kalau macam ni bagi saya memang soalan bonus je lah kalau keluar horizontal surface ni. Alright. Sebab apa? Bila incline plane, satu sistem coordinates dah kena shift macam ni. Alright, then force. Ni dah bergerak sebenarnya ni. Tak cantik dah. Sekejap saya gerakkan balik ni. Tak cantik ni. Dia kena ke atas sikit. Tak nampak yang bawah. Kejap kelas. Saya nak betulkan sikit ni. Ni mana? Okay, harap awak nampak lah. Alright, so for case inclined plane, okay, so bila kata inclined plane, even 10 degree pun, even the angle here is 10 degree. Okay, even this angle 10 degree ke 15 degree, but still it affect the value of the acceleration. Maksudnya we still cannot ignore. Okay, walaupun macam cakap lama 10 degree je, berapa je beza dia kan. Tapi but even perpuluhan belakang je yang beza, but you need to consider this angle. Then for case macam ni, kita ada, we need to shift our coordinate system. Okay, so that kita dapat our force, tak apalah arah sini kan. Okay, so maksudnya kita dah boleh matchkan dengan kita punya coordinate system ni, which is X. So your force in this direction sama dengan X. Then your normal sama dengan Y. Your frictional force sama dengan axis X and then W je. That different. Okay, that's the reason why we shift the coordinate system. If not, then you need to resolve three forces. Okay, which is kalau awak nak stick juga ni X, yang ni Y. Okay, so tak ada masalah. But the problem is 1, 2, 3 forces are not mesh with this coordinate systems. Cuma W saja macam ni. So bila tak mesh macam tu, then maka you need to resolve all these three forces. So that's why kita tak nak. So kita nak elakkan benda tu, then we shift the coordinate system. So then only one sahaja that we need to resolve. So again, I hope that you still remember how to resolve this vector. Okay, contoh macam case yang ni. Alright, then this is Wx, this is your Wy. Okay, sebab W arah sini, which is not in Y and it's not in X component, then you need to resolve so that it go to its component lah. Bolehlah kita masukkan sama Wy ni. Kita boleh kenakan dengan N, F, Wx, F. Boleh gang sekali. Faham tak? So kalau dia W dia je, kita tak boleh buat apa dengan dia. So that kita masukkan dia pada gang dia. So Wx masuk gang X. Wy masuk gang Wy. Barulah boleh mudah we solve the problem. So the angle, how can we get this angle? So kita ambil cara law of angle ke nama dia. Entahlah, trigonometry ke. Dan penting yang ni samalah. Angle sini sama dengan angle sini. Sebab apa? Sebab ni kan. Ni. So yang ni pun yang ni macam tu lah. Lebih kurang kot. Dan so right angle triangle. So dia bila suruh dia macam ni sama. Okay. Alright. So for net force X equal to MA. Again ada acceleration. So equal to MA. Alright. So for force. So we have three force on X axis. So consider all. So what's to the right minus to the left. So we get this equation. Okay, so we get this equation. Okay, so cantik lah kan. Bila sampai dapat equation ni memang cantik. Sebab kalau awak guna equation ni saja, markah tak dapat markah tak dapat. So kena buat dalam bentuk equation ni sebab this equation then you derive sendiri, then we will give you marks. So guna equation yang kita beri tak dapat markah lah. Alright. So MA, so WX tadi dah jadi apa? WX dah jadi mg sin theta. So kita expand siap-siap. Mg sin theta, so that nanti we can substitute their value nanti. Okay, bila awak dapat case ni lah. Alright, yang ni saya cuma bagi dia punya template saja ya. Alright. And then Y perpendicular to the inclined plane. So Y we have for in the component Y we have normal equal to mg cos theta. How we get cos theta? Again, this one you need to refer back to your punya vector yang hari tu kita belajar tu masa first weeks tu. Okay, during our first week lesson tu. Alright, so we get, since the angle is here, then for Y we get mg cos theta. Alright, so this is the template lah kalau case inclined plane. So that angle there, tak kisah berapa pun, kalau awak ingat how to form this equation, then awak dah menyelamatkan diri awak lah. Cuma kadang adalah tambahan connected dengan puli lah pula lah, apalah, ada block lagi lah. Yang tu tak ada masalah. Semua kita boleh settle. Alright, sebab equation tu you do yourself. Okay. The basic one is only this one. Okay, net force Y equal to 0. This is our first motion law. This is our second law of motion. So apply these two concept. Then you may find that equation. Alright, now we go to case lift. Okay, so case lift, dia bermain pada Y. exist saja. So one dimension which is y exist saja. Cuma kita tengok apa yang berlaku kalau kita duduk dalam satu lift. Alright, for lift that moving upward at a uniform velocity. So what happened? Bila uniform velocity, what happened to the acceleration? Acceleration equal to 0. When the acceleration equal to 0, then we apply first Newton's law and equal to mg. Alright, which is pendek kata, your apparent weight, your normal force, your apparent weight, okay, we equal to your weight. Maksudnya kalau kita letak balance kat sini, penimbang kan, penimbang. Okay, then we will get our weight yang asal macam kita tak naik lift. Macam tu. Alright, and then when lift moving upwards at a constant acceleration, then we'll see how it affect our apparent weight. Bila dia naik ke atas, perasan tak kalau kita naik lift, kita akan rasa macam berat. Mana yang sedia berat, macam saya sedia berat, kita akan rasa makin berat. Macam tu. Dan kalau letak balance kat situ, memang psycho jugalah kan, rasa macam nak diet terus lepas tu kan. Lepas turun lift tu rasa macam nak diet terus. Sebab apa? Sebab, okay, apa tambahan tu disebabkan apa? Is because of we have another acceleration. Okay, going upward. Right, then we get this equation. So your apparent weight now akan bertambah sebanyak a value of MA. Okay, that's why lah your apparent weight akan jadi berat. Dia tak sama dengan weight awak yang sebenar tu lah. And then for third case, okay. For third case, yang ni paling best untuk orang yang berat macam saya lah. Dia suka turun lift je lah. Naik lift tak suka, rasa berat. So turun lift dia akan rasa gembira. Why? Sebab bila dia tengok berat dia, kalau kita letak mass balance kat situ, okay, bila kita tengok berat kita, apparent weight kita akan ringan. Sebab apa? Kita akan minus dengan a value of M A. A value of M mass kita times dengan acceleration. So ringan sangat ringan bila kita turun lift. Macam tu lah, sama juga. Dia macam-macam, banyaklah case dia kalau macam sekolah. Masa kat sekolah awak biasa case apa? Cikgu bagi roller coaster, naik buayan, semua tu lah. So basically yang macam ni je lah. Okay, the normal tu. Cuma again macam saya cakap, how to draw your normal. Kalau for case yang macam ni, normal kena 90 degree dari plane. So kalau plane kat sini, so contoh ini adalah awak. Alhamdulillah. So your weight in this direction, weight akan sentiasa sama lah. Your normal akan here, this is your normal. So no longer same with your weight. Okay. So kalau naik roller coaster pula ataupun motocross, dah sampai ke atas pula kita ni kan. So betul kena tonggeng kepala tu rasa. Sebab apa? Sebab normal awak dah ke bawah sini. Weight awak pun ke bawah sini. So yang memegang awak cuma apa? Cuma tali pinggang tu je. Kalau pernah naik roller coaster lah. Saya tak suka lah naik benda tu. Takut kan. Alright, so again your N is also known as your apparent weight. And your W tu is your true weight lah. On Earth. Macam tu. Buat beza lah ya. Okay kelas, so far so good ya. Saya bagi slow-slow je ni ya. Saya tak nak laju, saya nak awak betul-betul faham, bagi awak betul-betul skor bab ni. Sebab kalau bab awal-awal ni awak skor, insyaAllah lah setakat 50% dalam tangan tu. Macam tu, midterm tu memang boleh settle lah 100% markah dah boleh dapat kan. Midterm bila? Midterm bila? Tak ingat bila, tapi macam nak dekat dah. Sebab
September.
September. Bulan depan lah. Midterm bulan depan. So sampai mana lesson midterm nanti kita kena tengok kat tu. Okay, sebabnya midterm awak saya tak sure lah berapa persen. Biasa 20. 20 ke 10%? 20, this time saya tak tahu sebab saya lama dah tak mengajar. Alright, so okay, let's proceed to the yang sebenar, okay. Yang macam simple tadi tapi kita complicatedkan sikit. Okay, kita bagi force in this direct at this angle. Okay, maksudnya horizontal punya case. Okay, so ini yang kita ambil dari case horizontal tadi. Okay, but the force kita bagi force yang ada direction sikit lah. Sebab kalau kita logiknya kita tarik kotak yang bertali, kita akan make an angle kan. Okay, so tengoklah sama ada. Nanti bila kita kira ni, so awak tahulah macam mana nanti mana yang nak jadi engineer bila awak masuk kalau macam mana? Kalau awak masuk bidang yang macam bukan engineer, then tak nampak sangat lah the application apa yang awak belajar masa ni. Sebab nanti even kalau awak masuk engineering pun sebenarnya dia back to basic. Awak apply apa yang kita belajar masa ni je. Macam calculation. Macam nak tarik barang tu bagi ni sikit. So that's itulah fungsi engineer kat situ kan. Kalau dekat site tu. So nanti dia lah yang tolong kirakan semua. Oh okay ni kena kira macam ni. Okay berapa angle yang sesuai semua macam tu lah. Yang ni nampak lah macam kita kira macam tarik kotak. Macam main-main kan. Okay but in application dia sangat besar contribution dia. Even nanti kalau awak masuk degree engineering pun awak tak ada belajar apa pun, awak belajar benda yang macam ni juga. Macam tu je. Okay. So kalau awak punya ni dah mantap dari sekarang, then okay, no problem kalau awak nak ambil engineering apa-apa pun okay. Okay, sebabnya lagi satu engineering bukannya fizik saja, ada macam-macam kan. Okay, alright. Alright, so for this case, 20 kilogram box. Okay, so kita nak tarik. So biasanya bila box tu tinggi ni, takkanlah kita nak tarik sama level dengan dia kan. Nanti kita penat pula. So kita tarik ikut keselesaan kita. So we give an angle here which is 30 degree above horizontal. Above horizontal, pull by a force. Okay, ada acceleration ke tidak? If a coefficient of static friction. Coefficient of static friction tapi dia cakap box move box move at a constant speed. So terjawab ke tidak persoalan kita, ada acceleration ke tidak? No acceleration sebab dia move with constant speed. Calculate. Bila kata calculate sebenarnya dia macam mudah sikit sebab calculate ni dia fokus pada kita calculate. Kalau kata determine then you need to find both. Macam saya cakap lah. Maksudnya your value dan juga direction. Tapi kalau calculate tu mungkin awak boleh bagi the magnitude saja. Tapi again macam saya cakap better bagi jawapan lebih, jangan kurang. So kita tahu normal reaction force or force is one of the vector, then kawankan dia dengan dia punya direction. Even the direction is only upward, only to the right, which is we don't need to calculate pun sebenarnya. Okay, tapi biasakan diri awak untuk sensitif dengan when we talk about vector. So that orang clear dengan apa yang kita nak cari, nak bagi, nak sembang. Okay. So dia kata static friction is 0.3. So dia masalah. Maksudnya dia ada static friction. So bila kita nak lukis free body diagram dia. So first tanya normal reaction force. So at first again kita determine the body. So this is the body that we want to find the normal force semua tu lah yang persoalan tu kan. On this body. Okay. So we draw the free body diagram. So this is your applied force tadi. This is your frictional force. Okay, in contact with your punya ni. So dekat situ lah akan keluarnya your frictional force which will always opposite direction to the applied force. Okay. And then your weight mg in this direction always towards the center, towards the earth. Right, and then normal force akan ada again. Why? Because dia atas betul-betul lie in contact with the plane. Alright, then what we need to do is after we settle, determine all the forces act on this box. So macam ada satu benda yang tak kena lagi. Sebab satu benda ni dia tak match dengan kita punya coordinate system X and Y. Dia tak boleh masuk gang lagi. So kita tak boleh buat equation lagi. Jangan tergopar-gapar sangat. So relax. Then we need to carikan gang untuk F ni. Right, so we have this one for your X component. So dah ada gang, so kita boleh gangkan Fx cos 30 gangkan dengan your frictional force, your F sin theta degree gangkan dengan normal force and minus with your mg. Then we can write your complete equation and find your normal force. Normal force to where? Where is your normal force? Even from the component dia berada pada komponen Y. Tapi kita buat net force X equal to 0 and from here we have also normal force dekat mana dia berada dalam frictional force. But here we still cannot solve. Okay, since we have two equations, then we need to find another one equation from the y-axis. So from the y-axis, no problem. Fy kita tahu the net force equal to 0. Then we can make another one equation. So normal force plus dengan gang-gang dia yang seterusnya tadi. Then you may find another one equation and solve these two equation and you find your normal force. Okay, macam tu. Alright, and then therefore the applied force is given by, ni dah memang dah senang sangat lah. Ini bukan Newton ya kelas, ini bukan Newton ya, ini normal force tadi. Okay, normal force. So ini apa tadi? Ini static, kinetic, apa tadi? Static coefficient, static frictional coefficient, coefficient static friction, apa-apalah susunlah sendiri. Okay, and then therefore the applied force is given by force equal to 57.9. Yang ni Newton ya kelas. Yang ni pun Newton. Yang ni normal force. Itulah kan, kena bagi tahu juga ni. Takut awak tu tengah makan ke, tengah buat apa kan. So saya bagi tahu lah. Takut nanti apa tadi madam? Kenapa ada 2N pula ni madam? Ni unknown yang baru ke? Tak. Ini dah Newton ya. Okay, so ni normal force yang kita nak cari tu. Ataupun saya rasa kejap dekat Suwi dia pakai apa? FN FN kot. Dia tak pakai N saya rasa. So it's up to you lah. Static friction force, then ambil je lah your Fs equal to mu Sn equal to 50.1 Newton. Another example, kita tengok another example, sabar ikhlas baru sejam rupanya. Alright. So another one example is on inclined plane. Okay, so inclined plane, dah on inclined plane. Force applied pun ada angle lagi. Okay, mencabar. Tapi ada masalah tak? Tak ada masalah. Kalau, if you know the step, okay, on solving this type of problem. Okay, tadi incline, kan saya dah bagi basic dia. Okay, cuma penambahan dia adalah force dia sekarang ni tak menyedangkan hidup kita lagi. Okay, dia menyusahkan kita. Jadi kita kenalah carikan gang untuk dia. So again, shift your coordinate system. And first one, you need to find the normal force, net force, acceleration. So determine normal force. So nanti bagi juga dia punya direction ya. Even memang kita tahu ataupun awak fikir examiner pun tahu mestilah ke atas kan normal force. Tapi bagi tahu ya, bagi tahu dan plane system yang awak shift pun kena bagi tahu. Even saya cakap okay standard memang kalau incline plane memang kita akan shift macam ni. But again you need to show your plane system, coordinate system. Show your coordinate system to your examiner. Mesti kena tunjuk every time you do the question on this. Okay, sebab apa? Sebab kita nak nampak. Kita nak benda tu jelas. Awak suka kan benda yang jelas kan? Macam tu lah. Examiner pun sukalah benda yang jelas. Sama je kita ni. Okay. So macam ni. You need to always put this one. Alright, now we start to do the free body diagram. So it's up to you lah. You want to start with the complicated one ke, the easiest one ke, then it's up to you. So again, bila dia tak masuk dengan gang X ataupun gang Y, kita carikan gang dia dan kita resolve dengan cara we resolve. So F cos 20, F sin 20, then F sin 20 gang dengan normal force with your mg cos 30, mg sin 30 ni ada ya, which is daripada mg. Jangan terlupa ya, sebab mg ni we need to resolve juga walaupun nampak dia arah macam y. Tapi since kita dah shift kita punya coordinate system, then we need to resolve our mg. So mg cos 30 degree y because the angle is here, 30 degree is here. Alright, and for x component mg sin 30 degree, then we form equation. So berapa unknown yang kita ada? Macam banyak. Tapi tak apa, tarik nafas. Tarik nafas, we solve one by one. We start with component y since net force y equal to 0. So easier for us. And the question pun tanya apa tadi? Normal force kan? So focus on your y terus. Maybe we can get direct, but unfortunately, luckily you can get it directly since you already have all the value. M ada, G ada, apply force also have, then this is your normal force. Settle masalah. Okay. And then B, you need to find your net force. Net force on X component. Sebab apa kita terus assume net force X component? Sebab tadi net force untuk Y sama dengan kosong. That's why kita focus on net force tu kita terus equatekan dengan net force X. So any force that act on X plane, then you need to list down all the forces. Then what's to the left, what's to the right, minus to force in to the left. Okay, then your F net is equal to this value. Okay, so just substitute saja all the values and find your F net. Alright. Then you need to find acceleration. Okay, so acceleration, use your F net. Since we already find the F net, effective force, resultant force, then we equate dengan MA sahaja, then you may find your value of acceleration. And again, since acceleration is vector, so please provide also the direction. Even your direction you already show in your diagram, but apa salahnya mention lagi sekali kan? To the right ataupun along the x-axis as shown at the above drawing, apa coordinate system yang baru tu kan. Boleh. Suka je Mina tengok. Cakap jelas budak ni bagi jawapan kan. Alright, then the question asks you to find a distance. Kan, distance. So, distance. Kenapa distance? Distance biasa displacement. Why displacement pula kan? Displacement biasa dekat chapter 2. Ini dah case force ni. Kenapa ada displacement? Kenapa pula tak boleh kan? Kita ada acceleration. So tak ada masalah. So acceleration ada kan? So dalam acceleration ni ada segala-galanya kan? Alright, so we can use the motion equation ni. Motion equation kita. So displacement equal to ut plus half at. So at first the block start from rest, okay, and then dia kata cari masa untuk dia bergerak 30 meter. So substitute 30 meter there. Alright, okay. And then sebab yang tu kita dah ambil dia sebagai x kan, so no problem. Then substitute your acceleration, then you may find your time for the blocks to move along 30 meter is 4.94 seconds, right? So this is some exercise, very complicated. Then if you able to answer this, then no problem lah untuk awak menjejakkan kaki ke Dewan Peperiksaan dengan confidentnya macam tu. Okay, exercise. Exercise lagi. Dah habis. Alhamdulillah. Right, so I hope that I'm not too fast and not too slow and everybody can catch up all the lessons that every presentation, okay, every lesson that I